All right. The afternoon session, the first one, is on astronomy. I'm a lapsed astrophysicist who has been working on the history of astronomy for a long time. I'm Owen Gingrich from the Harvard-Smithsonian Center for Astrophysics. I had a long connection with the John Templeton Foundation, having been among the earliest of the advisors and for a while a trustee of the foundation. So I'm very happy to have two excellent astronomy speakers in this session this afternoon, and we will begin with Jennifer Wiseman from the American Association for the Advancement of Science and also NASA. So you can introduce yourself a little bit further.
Okay. Thank you so much, Owen. What Owen didn't say is that when I was a graduate student at Harvard, I was a teaching assistant for Owen in his fabulous class that he taught there. And I learned much more from that class than any of my regular technical courses that I was taking. So thank you, Owen, so much. I am an astronomer. I wear two hats. I work with the Hubble Space Telescope program at NASA's Goddard Space Flight Center outside of Washington, D.C. But I also direct a program of outreach for the American Association for the Advancement of Science that's called the Dialogue on Science, Ethics, and Religion. And I encourage you to visit our website and learn about some of the things we do, which I'll mention in a moment. But shall I proceed, Owen?
You should proceed,
okay.
But I'll sit down in the front row so I can see all your wonderful slides.
Okay, that sounds good.
Do you want to move to the... you can look over your shoulder.
I'm going to ask if we could turn down the lights a little bit. I know that may make it difficult for the... Would that work for you? That's perfect for me, as long as people don't fall asleep, please. So. This talk is going to have 3 or 4 quick parts that I have to fit into 25 minutes here. But and in fact, the more lights you can have off, the better for these slides. But whatever you need for the video is okay. I'm going to give you a little overview of the beauty of the universe and this new phenomenon that we call exoplanets, which is the detection of planets outside of our solar system. That's where the exo comes in. I'm going to talk a little bit about societal responses to looking for planets and potentially life outside our own solar system. And we can think a little bit about our own response to such matters. Again, let me advertise also this Dialogue on Science, Ethics, and Religion program that I direct, the DOZER program. It is largely funded. Our projects are much funded by the John Templeton Foundation, and we very much appreciate that. The DOZER program facilitates communication and understanding between scientific and religious communities. So we sit within a scientific society, the American Association for the Advancement of Science, and we are engaging religious communities on topics and issues where science and religion touch. So one of the things that we are interested in, which was brought up this morning, is how to help bring more science into the education of religious leaders and into seminaries, and that's one of the issue areas that we are very interested in helping to support. It's interesting to me that the AAAS is quite supportive and interested in helping with this dialogue, because the AAAS motto is advancing science and serving society, and they feel like it's very important to serving society by helping the advancements of science reach and communicate with in a two-way direction with the public and religious communities. Okay, so let's do just a little introduction to our magnificent universe. And again, I don't know if it's possible to get the lights down, or is that something that's not okay? Now I'm.
It's a problem with the,
okay.
with the filming of the
I see.
streaming of the content.
Okay, well, the slides are more important than I am at this point on the film. But in any case, I hope you can get a sense of the beauty of this particular cluster of stars. Now, this is an image that was taken with the Hubble Space Telescope, which is an orbiting satellite telescope in space, as a test image. This was taken just 3 years ago after a new camera was put on the telescope. This image was taken just to test out the camera. It turned out to be such a spectacular image that we are using it for other kinds of advertisement as well into the capabilities of Hubble, and just showing you that the enormous beauty of just one particular cluster of stars in our galaxy known as Omega Centauri. This image alone shows you something about the numbers of stars, the variety of stars. This one cluster has, as you can see, many different types of stars. You can see the colors, reds, blues, yellows, whites. You can also see different brightnesses that appear as though they are different sizes here in this image. Just pictorially, you can see what I think St. Paul mentioned, that star differs from star in splendor. And so with this audience, I think it is reasonable to be inspired by philosophers and theologians. So here's a nice paraphrase of a quote from Kant that I believe is on his tombstone, that two things continue to fill his mind with ever-increasing awe and admiration: the starry heavens above him and the moral law within him. I find that quote quite interesting, that these two things, I think, still continue to stimulate discussion both in academic circles and in religious circles, and that is the starry heavens, the cosmology that we're going to hear about, especially from Chris, and also what's going on within us. Why do we have a sense of justice? Is there such a thing as true altruism? Things like that are still the issue, two of the big issues of the day. And then theologian John Calvin mentioned, even with the astronomy of his day, that he said astronomy is not only pleasant but also useful to be known. It cannot be denied that this art unfolds the admirable wisdom of God. I like that quote. So with that permission from Calvin, we'll go on. Let me give you some context for planets. Planets exist around stars, and there are at least 200 billion stars in our galaxy alone, the Milky Way galaxy. And then, of course, we now know there are other galaxies. In fact, there are hundreds of billions of galaxies in the observable universe. So if you do the math, the numbers get quite large. This region of the sky is familiar to many of us as the Orion region, and the boxed area is popular even with binoculars. You can see fuzziness around some of these stars. We call any fuzziness, we call it a nebula in astronomy. So if you look around some of these stars, you'll see fuzziness, which is really bright gas enshrouding these stars. And if you zoom in with the Hubble Space Telescope, this image was taken by a very good telescope on the ground, but if you zoom in with Hubble, you can see in that lower region what you find is that these very bright stars, which have recently formed out of this interstellar gas, are now ionizing the material around it. They are sending energetic photons of light to the surrounding gas, which separates protons and electrons from atoms, and when those atoms recombine, you see beautiful colors. All this is evidence that stars are continuing to form in a very vibrant fashion in our galaxy and in other galaxies as well. We live in an active universe. And then these clouds, these dust clouds, gas clouds, fill the space between stars, and the whole collection of stars and gas that are gravitationally bound we call a galaxy. So this is an example of a beautiful galaxy, one of hundreds of billions that have been, that we know of in our universe. This one, again, imaged by the Hubble Space Telescope. Most of my talk today is going to be zooming in on regions we can observe or think about from the position of our solar system. We cannot get outside of our own galaxy to take a picture of the Milky Way galaxy we're in, but we believe it looks something like this, a spiral galaxy with our sun about 2/3 of the way out. And we are now avidly looking at stars in our neighborhood around the sun and within our quadrant of the galaxy, looking for stars that have other stars that have planets around them. The Hubble Space Telescope is one of the telescopes facilitating this. It's above the atmosphere, so that's why we get such sharp pictures. It's not such a big telescope compared to others on the ground, but it is greatly aided by being above the blurring effects of the atmosphere. And here's an example where I think the development of human technology over the years, over the centuries, has enabled us to understand scientifically where we fit in the universe. And that in itself has fed theological and philosophical thought. So this is a place, I think astronomy is an obvious place where technology, theology, science all kind of come together in mutually supportive ways. This chart shows you the timeline from Galileo's time on the left here to modern times on the right. And the upper axis here shows you the sensitivity improvement of this technology over what you could see with your bare eye looking up into space. So in Galileo's time, he could make out that the lights around Jupiter were moving in an orbital fashion, and he concluded that that must be, in fact, the architecture of the solar system itself, that planets are, in fact, orbiting around the sun. And over time, telescopes and eyepieces got better and better. Each tick mark here is 10 times better than the one below it, so this is a logarithmic scale, showing that over the centuries, we've vastly improved our ability to see and contemplate the universe. We have photography entering into the scene in the late 19th century and early 20th century, and then we have electronic recording that gave us much better abilities to record dim, faint objects. And then with the advent of going into space above the atmosphere, taking our telescopes high and dry, we achieved 2 orders of magnitude better sensitivity. And with Hubble, we've been sending astronauts up regularly to make it even better with new instruments. The last servicing mission, SM4, took us way off the charts here. So this is an example where I think technology has informed even our sense of philosophy and possibly even theology with what we're seeing, because we can start with a ground-based image such as this one taken from the ground, zoom in to one of these star clusters, and with the resolution that we get from something like the Hubble Space Telescope, we can differentiate star from star and see what I began this presentation with, which was the minute detail of some of these fantastic regions in space. And in fact, what we found is that around many of these stars, we see something quite interesting. We see a dark, dusty-looking disk, and it turns out that young stars, as we see them, tend to all have these dusty disks around them as the star forms, especially in our recent epochs of time. We get a dusty disk that is, in fact, the region where planets form. They are about the size of our solar system, maybe a little larger in some of these younger objects. Quite interesting. We're now finding evidence of planets within these dusty disks around young stars. Most of these disks tend to dissipate over time, but leave some material behind. So even in our own solar system, we still have some dust and debris left around our own sun, along with the planets. We now know that there, as I mentioned, are 200 billion stars in the galaxy. This is an image from the ground of near the center of the galaxy, showing you the enormous number of stars near the center of the Milky Way in this dusty lane around that region. One of them is our sun, so it makes you wonder, are there other stars that have planets like our own solar system? And in fact, is there another Earth out there, and is there life? Now, we're not the first ones to have thought about this question. Obviously, people have thought about this, philosophers, for a long time, and in more recent times, science fiction has made a heyday out of this thinking. But we even have Greek philosophers speculating about other worlds, Epicurus writing that there are infinite worlds, both like and unlike this world of ours. Now, the use of world may be a little different than what we use now, but nevertheless, he said, we must believe that in all worlds there are living creatures and planets and other things we see in this world. Well, St. Augustine commented on this in the City of God, and he seemed to say that that we need to think of some way to reply to those who think that the creator of the world might have had difficulties about choosing the time of creation. And if that's so, there might be difficulties imagining what would happen in the infinite spaces of creation. And in fact, he said, would it not follow that if they believe that there's infinite time for God to make the world and to choose and where to make the world in the epoch of time, could it not also follow that these people he's discussing must adopt Epicurus' dream of innumerable worlds? Now, the context of this, it puts doubt in that St. Augustine, I believe, does not think that it's really feasible for there to be this innumerable worlds, but he does mention it as a philosophy that must be addressed, and I find that interesting. If we fast forward now quite a few centuries, we find medieval scholars talking about this idea. In more astronomical context, we have Giordano Bruno saying that there are countless suns and countless Earths all rotating around their suns in exactly the same way as the 7 planets of our solar system. The countless worlds in the universe are no worse and no less inhabited than our Earth. So pretty forward thinking for that epoch of astronomy. Of course, you all know what happened to Bruno, so hopefully we can have this discussion without being burned at the stake ourselves. So what has happened scientifically in terms of looking at for planets and worlds outside of our own solar system? We've known throughout recorded human history of some of the big planets in our own solar system. And then, of course, with the advent of the telescope, we were able to discover Saturn, moons of Saturn, Uranus, Neptune. In the 20th century came Pluto. And then in more recent decades, we found all kinds of rocky bodies, asteroids, comets, and now what we call dwarf planets, hundreds of these objects orbiting our sun in this disk of debris left over from the formation of the sun. And then came the early 90s when exoplanets were first detected, and I'll explain to you how that happens in a moment. But this is a collection of some of the famous names of people involved with the first certain detection that there were objects orbiting other stars or stellar objects. This enterprise took off in the 1990s. How do we do this? How do we detect exoplanets or extrasolar planets, as they are sometimes called? Well, it's not easy because these objects are very small. They're orbiting a very bright star. They can get lost in the glare. So you have to use almost always an indirect technique. The most popular one has been to look not at the planet, but to look at the star. And if you see the star wobbling in a regular fashion, it can mean that a planet is tugging on that star gravitationally. Or if that planet is orbiting and it happens to be orbiting along your line of sight to the star, then every time that planet goes in front of the star, the amount of light will dim slightly. That's called transit detection. And then, of course, what you'd really like to do is take a picture of the star, image the exoplanet. But as I mentioned, that's difficult because you have to suppress that bright starlight in order to be able to see the planet. So here's a graphic of what tracing a star wobbling in the sky in the plane of the sky might look like. And you can pretty easily calculate, if you can map out the wobble of a star, you can pretty easily calculate the mass of object or objects that might be tugging on that star. And likewise, if you see the wobble along your line of sight, that can help you detect one of these planets. That's been the most popular technique. These astronomers down here, Jeff Marcy and Paul Butler, are well known for discovering the first hundreds of these objects using powerful telescopes on the ground. They observe when a star appears to be blue shifted as it's wobbling toward us and red shifted in its path away from us as it's periodically shifted by the tug of its unseen planet. And that phenomenon allows us to gauge the type of object that must be tugging on that star. Then quickly, the nice method of blocking out the star with a coronagraph, as we call it, allows a planet to appear that might otherwise be lost in the glare. That is the most intensely studied new technology right now because we want to be able to take images of planets and also look at the spectrum of their light. Future telescopes are going to concentrate on this method of finding extrasolar planets. But we have to remember that stars are 1 billion times brighter than these planets lost in the glare. So it's kind of like looking at a lighthouse and trying to find a firefly. I don't know if you have fireflies in Europe, but we have them in the US. And they're little bright flies, but they're very small compared to a lighthouse. So that's what it's like trying to find a planet next to a star. But we're doing it. So here's an example of a planetary system that was directly imaged by a telescope on the ground called the Gemini Observatory. The star has been blocked out here so that you see 3 planets appearing in the outskirts of this star. So we're beginning this technique of being able to take images of certain kinds of planets. These are all very big planets like Jupiter, but we of course would like to take pictures of things like Earth. And then, of course, I mentioned the transit method where the planet moves in front of the star and the total amount of starlight dips. This is a popular method for the Kepler Space Telescope. You see in the bottom right there, that's another NASA space telescope looking at transits to determine the number of stars statistically that have planets. And this is what a transit looks like. Whoops. From an artist's conception point of view, the total amount of starlight dipping with every transit of an orbiting planet. You don't see the planet, but you see the starlight dipping. And you can tell a lot about that planet because of this. You can tell something about the size of the planet, and you can tell something about its atmosphere because of the light coming through the outer fringes of the planet's atmosphere. All these techniques together are giving us hundreds of new planets. So this is a histogram showing you over the last couple of decades the numbers of new planets outside our solar system detected every year. And you see in the 90s, they were in the onesies and twosies. And then as these techniques improved over the years, the numbers discovered each year began to rise exponentially, until finally, with Kepler, we are discovering hundreds of planets every year. The last bar over here is this year, but it only goes through May. So if we could update this chart, it would be a higher bar than the one before it. So we're really detecting them now by the hundreds. And in fact, there are thousands of candidate systems now for planets around other stars. And we can even look at their sizes now. So we have estimates here from the Kepler observations of what sizes these planets are. And so from the collection as of February, we see that most of these planets are the size of Neptune. Some of them are Earth-sized or a little bit bigger, and a few of them are as big as Jupiter or larger than that. It is quite amazing that we've gone from science fiction to scientific statistical analysis within 2 decades, when in all of human history before that, we haven't even known if there were planets around other stars. So this is an amazing time to be alive right now. And of course, the hope is to be able to observe and analyze planets near our own. Lots of artist conceptions of real data, because like I say, we don't get many images, but we are starting to characterize the atmospheres of these planets. Some of them have sodium, carbon, hydrogen, and oxygen. Some of them show water vapor in their atmospheres, so we're getting closer to what we might consider might be a habitable world. That's one of the hopes. Just a couple of weeks ago, it was announced that there was a planet detected in the Alpha Centauri star system, which is the closest one to our solar system. Very exciting. It's an Earth-sized planet. It's too hot to harbor life. It's too close to its parent star, but nevertheless, it shows the possibilities for planets like Earth, even in our own neighborhood. And this would have made the front page of every newspaper in the world had it not been that it was announced the morning after the United States presidential debate, the night before, candidate debate, which took over the news. So let me finish in my last 5 or 10 minutes here is about looking for life on these planets. Oh, I thought I had 25 minutes. Okay, well, let me, you promised 25. I have 5 minutes? 25. Okay. All right, let me just mention that we are looking for signs of biological activity on some of these other planets. We would like to know if they hold plants, signs of life. This is all done by studying the atmospheres of these planets, and we need to rule out other explanations. We also need to figure out what time in the history of that planet that we're looking, because our own Earth's atmosphere has changed in composition over time. So if we're looking at another planet, it might be at a different evolutionary stage if it has life, and its atmosphere might reflect that. So in my last 45 seconds, let me mention the societal implications of what might happen if we find life. How are we going to respond to the detection of life? Well, Ted Peters over here is famous for his studies of how different religious groups might respond if we end up finding life elsewhere. He did a survey as to whether different religious groups would face a crisis if an undeniable detection of intelligent life was found. And he found that most religious groups self-reported that they did not believe they would face a crisis if intelligent life were found elsewhere, that their religious traditions could embrace this. However, if I recall correctly, if they were asked about other religious traditions, they would commonly say that they felt the other religious tradition might in fact have a crisis. So people have a perception issue. There have been scholars throughout the history of Islam that have speculated on the possibilities of life beyond Earth. I'm just going to move through this. In Christian theology, we have the issue of God becoming incarnate, God coming to Earth in human form to save us. The question then becomes, would this apply on other planets if there's intelligent life? And we have the verse from 1 John that says Jesus Christ is the atoning sacrifice for our sins in Christian theology, and not only for ours, but also for the sins of the whole world. Does that include the whole universe? We have to grapple with that question. With that, there's been a conference, a Catholic conference on astrobiology discussing these very questions, and whether or not there is a deep theological problem with having intelligent civilizations on other planets. Most of the leaders there felt there would be no issue, really. It could be embraced within Catholic theology. But Paul Davies, physicist and philosopher, says not so fast. He says actually the real threat to Christianity in particular would be in the discovery of extraterrestrial intelligence, because if there are beings elsewhere in this universe, Christians are in this horrible bind. They believe that God became incarnate in the form of Jesus Christ in order to save humankind, not dolphins or chimpanzees or little green men on other planets. So there is some discussion about this philosophically, and I believe O'Collins said it right when he said in the middle paragraph here, Father O'Collins said, anyone who thinks the doctrine of original sin is more important than Jesus being the universal Savior already has their priorities out of line. All right, let me close here. Protestants have thought about this as well. C.S. Lewis wrote about the potential, the moral state of civilizations on other planets in his novel Out of the Silent Planet. Billy Graham mentioned it. And we also just need to think about whether this affects philosophically our significance, our sense of human significance, because we now know, of course, we're not in the center of the universe nor in the center of time. Will it affect our sense of human significance if we find out that we are not the only place for life in the universe? And I believe that is a philosophical question. We have to remember that even in Copernican times, according to Dennis Danielson, the not being in the center was actually considered a promotion, not necessarily a demotion. So this is a philosophical question. Biblically, the Lord has said in the Psalms that it's not our lifespan, it's not our place in space and time that make us significant, but it's God's choice. As for man, his days are like grass, but from everlasting to everlasting, the Lord's love is with those who fear him. Praise the Lord, all his dominion. So let me close with our little planet Earth here with two philosophies of how to look at this and our place in space as we're finding planets and potentially life elsewhere. There's Carl Sagan's view. Who are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy, tucked away in some forgotten corner of a universe. Many people believe this as we're finding, these are galaxies, by the way, of billions of stars. Or the psalmist's view, who says, how majestic is your name in all the earth, O Lord. When I look at your heavens, the work of your fingers, the moon and the stars, what are human beings that you're mindful of them, mortals that you care for them, and yet you've made them a little lower than God and have crowned them with glory and honor. You've given them dominion over the works of your hands and put all things under their feet. He looks at the universe and our ability to see it and to be a part of it as a sign of significance. And I will close with that, and we can have conversation after Chris's talk. So thank you very much.